Pretty cool, dude. You want to talk about 0 to the 0 and why it equals 1? No, 0 to the 0 is undefined.
Well, it turns out the cool dude is actually right and Andy is wrong. And he keeps pushing this idea that 0 to the 0 is 1, which is not true. 0 to the 0 is undefined. You can define it to be 1 since it's undefined. You can define it to be 1, but that it's not the same thing as being equal to 1. If he thinks it's equal to 1, then will give us a proof that 0 to the 0 is 1. There is no such a proof. So it is undefined, and for convenience, in many cases, we define it to be 1. There are many formulas that simplify and that just are more compact and simpler if we define 0 to the 0 to be 1, like in the binomial theorem. Why is 0 to the 0 undefined? Because when we define the integers, we define the integers by its properties, and the properties, among others, is that the integers enjoy two operations, addition and multiplication. That is it. And these operations do not contemplate the operation 0 to the 0. It does contemplate the idea of 2 to the 3 because 2 times 2 times 2 is 2 to the 3, so it's just multiplication. But 0 to the 0, it's not contemplated by that definition of the integers. So to assign it a value, we have to define what the value should be. Now, if we take exponents beyond the integers and we define exponentiation in the real numbers, then we actually define those as a limit. We define what 2 to the 1/2 is as a limit. We define what 3 to the 1/5 as a limit. We define what pi to the pi is as a limit. And then we would have to define 0 to the 0 as a limit. And how do we compute pi to the pi? We compute it as a limit. We know how to do pi to the 3 because that's pi times pi times pi, and multiplication is defined in the real numbers. Pi times pi times pi is something. And then we can do pi to the 3.1 because that's pi to some rational exponent, and those are just taking some roots, and we know how to take roots of real numbers, also as some limit, by the way, but we know how to do pi to the 3.1, pi to the 3.14, pi to the 3.141, etc., and whatever that limit approaches, that's pi to the pi. There are several ways how to approach pi to the pi. I could approximate pi and the exponent at the same time or in different directions. And all of those should give me the same value. It should give me the same number all the time, pi to the pi. And it does. Then how should we compute 0 to 0? In the same way, as a limit. We don't know what it is, so let's try to assign it a value as a limit. Then you do 0 to some exponent that approaches 0. Well, that's 0 to the 2, 0 to the 1, 0 to the 0.5, and so on. Those are always 0, so that limit should be 0. But if, on the other hand, I keep the exponent to be 0 and do like 3 to the 0, 2 to the 0, 1 to the 0, those are all 1s. And as I approach 0 to the 0 in that direction, I always get 1. So I don't know how to define 0 to the 0, as a 1, and it turns out that you can approach 0 to the 0 in infinitely many different ways and get infinitely many different values. So it actually is undefined. We actually cannot make sense of the quantity 0 to the 0 from the real number point of view, which is the only point of view where you can actually make sense of the operation x to the y in general. Now, there are probably some mathematicians out there watching this video that are yelling at the screen and saying 0 to the 0 is 1 because it counts the number of functions from a set, from the empty set to the empty set. And that is just another way of defining what 0 to the 0 means. So it's a definition. You are defining the exponent operation x to the y as the number of functions from a set with y elements to a set with x elements, and counting how many functions are there. You are implicitly defining the operation, And when you define the operation that way, then yes, 0 to 0 is 1. I will make another video about this, simply just about this fact about 0 to the 0 equals 1 from the set theory point of view in a moment. But it is just a definition. It's just another definition of 0 to the 0, just as a way of counting functions. And it is convenient sometimes to think about x to the y when x and y are integers in that way. But if you are treating, for example, pi to the pi, then you cannot do it in that way. So that is a very limiting definition of what exponents mean. So in any case, 0 to 0 can be defined to be 1.